Hello, Richard and Alessandro. You're from the Woods Hole Research Centre in the States. Could you let me know what the research is that you're bringing to the COP?
Sure. Let me say. There are two of us here because I'm going to talk a little bit about how much carbon is released to the atmosphere globally from changes in land use. It's something we've been doing, but it gets updated every 5 years or so. So I'll talk some about those carbon emissions from land use change. And Alessandro will talk about a new data set that has to do with above ground stocks of carbon for all of the tropical forests.
And how these two go well together.
And how they fit together
Okay.
at the end. Sure, should I just go ahead with beginning it off? Okay, well, the emissions of carbon from land use change are responsible for something on the order of 10 to 20% of total anthropogenic emissions of carbon. Most of the emissions are from burning fossil fuels, but something on the order of 10 to 20% are from changes in land use, which is largely deforestation. But the emissions include uptake of carbon in regrowing forests, so it's really a net emission. And the Forest Resource Assessment of the United Nations, FAO, Food and Agriculture Organization, released last month their latest findings in terms of global forest area, rates of change. So it updated the information from 2005 to 2010, and we used that information on rates of deforestation, rates of reforestation, to calculate, with a carbon tracking model we have, to calculate the emissions from the tropics, but also globally, outside the tropics. And the estimates are that emissions are now about 10% of total emissions. The good news is that rates of deforestation have fallen. They're still considerable in the tropics. Something like 13 million hectares are deforested each year, but a decade ago it was more like 16 million hectares. So the rate is down some. It's still considerable, but the emissions of carbon from deforestation, from land use change, are on the order of 1 petagram of carbon, compared to fossil fuels, which is close to 9 petagrams of carbon. 2009 saw a reduction in fossil fuel emissions, which is by 2010 will be highest it's ever been again. So the economic decline reduced those, but it looks as though over the last 2 decades now, the emissions from deforestation have been declining, which is the good news. So I'll stop there, and I think Alessandro will talk more about some of the data that can be used in those calculations.
Okay.
Does that make sense?
We'll come back to you.
Okay.
Alessandro.
Yes, thank you. Well, in order to estimate the emissions from deforestation, one of the basic information that we need to know is what is the amount of carbon that is stored in the vegetation, so that when forest is removed, we actually can assign and we can know how much carbon is released into the atmosphere. Well, this type of information has been very difficult to generate. Usually is based on national forest inventories, but unfortunately for the tropical nations, there are very few updated and existing forest inventories. So what we did at the Woods Hole Research Center is try to generate a new data set that provide to tropical nation a baseline, a basic information on how much carbon is in their country, and for the first time we are providing maps. So we are providing also the spatial information of where the carbon is in the country. So to do this, we combine LiDAR satellite data with MODIS satellite data, and specifically design field observation that are used for the calibration of statistical model that derive carbon stock as a function of this satellite information. The good news is that the dataset is going to be available for free to all the nations, to all the countries. The dataset will be available online from tomorrow night after our side event, and each country can have access and use the dataset.
So what have you actually noticed in terms of where carbon is being stored and which countries are storing most?
Most of the countries, most of the carbon is stored in Central Africa and in South America. The Democratic Republic of Congo, Brazil, and Indonesia are the three countries with the highest carbon stock across all the other countries.
Just to make the pace, carbon stocks are highest in forests, but they aren't the same in forests everywhere. So this is a map which tries to identify variability through space in those carbon stocks. But any country with a large area of forest is going to have large carbon stocks. And if deforestation is happening there, that's what releases carbon to the atmosphere.
What do you think will be the impact of these combined results that you have?
Well, as Alessandro said, one impact is this will be information useful to countries that want to have a better idea of how much carbon is actually in their forests at present, what the area of forest is, and
to
how much
what result?
To what result? Well, it provides a baseline for how much carbon is stored there, how much potentially would be released if you were to deforest. I suppose you could turn it around the other way and say, look, here's how much carbon's there now. You could measure against that carbon that you accumulate. If you planted forest or encouraged the regeneration of forests, in subsequent measurements, you could see how much carbon had accumulated, and presumably that will be worth money someday when carbon is worth so much a ton.
Have you patented it? Yeah, okay, fair enough.
Yeah, I would like to add just maybe one thing. So one application of the data set would be, for example, for countries who would like to participate in RED, in the mechanism that is pretty much helping to reduce emissions from deforestation and degradation, is that some financial mechanisms that have been discussed at the UN, are actually based on carbon stock approach. And the carbon stock approach, what it requires is that you need to know how much carbon stock you have in the country, and the more carbon stock you have, as Keith was saying, there is more financial value. So it is information that is going to provide the country an order of idea of how much value they actually have in their own country as a function of carbon stock.
Is there any place that people are going to be able to get this information from you then?
I'm sorry?
You're going to give a website?
Oh, right, yes. So this dataset is going to be available from the WHRC website, and it's going to be online. People can just log in and download the data.
Should he give it now? Should he give the address?
No, that's fine.
I don't have the address.
But they won't be able to get that information from anywhere else. You're the only people with it.
No, we are the only one. It's this is the first existing data set of such a kind. So far, it's been extremely difficult to generate this type of information. I would like actually to say that there are similar data set as this one, but the resolution, the spatial resolution, the spatial detail of the information is much coarser. And in this type of data set, it's very important to have a significant spatial variability in the estimates. And so the data set that we release is at the resolution of 500 meters. And at this resolution is the only one available. So what we are saying is that every 25 hectare, for each 25 hectare, we will say, the data set will provide how much carbon stock is in these 25 hectares on the ground.
I see.
Historically, for almost 30 years, we've been estimating the emissions of carbon from land use change, from deforestation and reforestation, as part of the global carbon cycle. And over that period of 30 years, we've made the measurements, or we've made the calculations based on finer and finer spatial resolution. So, for example, in the beginning, we would consider all of North American forests as one unit, and assume that whatever got deforested had one value for biomass, one average for all of North America. And we've gotten to the point, as a result of the work that Alessandro talked about, of now something like 500 meter resolution. So if someone clears a forest now in North America, in Amazonia, we can attach a carbon value to the forest much closer to the actual forest that got deforested, as opposed to some average for the region. So the estimates should be more precise, should be more accurate. We're not completely there yet, because eventually we would want the resolution to be finer and of the same resolution as changes are happening on the ground. For example, if someone cuts down a hectare of forest for a rice field, we would want to know that hectare exactly how much carbon was held in that. But this is progress in that direction.
It definitely sounds like progress, but it raises lots of questions, because, like anything, it has to be used properly. Are there any problems that you would foresee in terms of like how you would safeguard its proper use?
Safeguard it from, sorry?
For proper use.
Well, let's see. I guess you want. I think you want in the procedure of calculating carbon emissions, you'll want to have some sort of MRV, I guess, is monitoring, reporting, and verification. So eventually all three of those will be required, which means, and the verification part means that you'll want presumably a third party checking to make sure that the stocks you used in your calculations and the rates of change in land use are in fact reproducible or verifiable from either satellite or on the ground. So that's in the language being discussed, but as you know, it has not yet been adopted.
Okay, so what kind of interest have your results found here?
You want to take a
How
shot?
have people reacted? Do they love it? Do they hate it? Are they not quite bothered?
Well, it's difficult to say, because it's really new. We are going to release the data set here at COP16 for the first time, and so we are really looking forward for people to get back to us with comments and so on. But some of the results are that, for example, we show that the amount of carbon stored in the vegetation is actually much higher than we previously knew, and this is going to be important, especially for carbon cycle studies, but also for mechanisms such as RED. We see that for some countries in the tropics, the previous carbon estimate, they are much lower compared to what satellite estimates are giving us today, and this is definitely interesting.
Some people will not like the fact that it looks as though the land use emissions are now only 10% of total human emissions of carbon, because it on the one hand, it makes it look like a harder justification for red. If red can only be made to account for 10% of emissions, it's a smaller and smaller portion of the pie. That 10% is lower than what even in the 1990s we estimated was 20% of total emissions. The reduction has come partly from reduced rates of deforestation, but it's come just as much from the fact that the fossil fuel emissions have increased so steeply. So the fraction coming from land use continues to decline, partly, as I say, from real declines in deforestation, but also just because fossil fuels increase. So it's a little bit, it somewhat undermines red in the sense that if there were no emissions from land use change, then it's hard to justify putting red into any kind of negotiation. I turn it around the other way and just make the point that tropical countries have already reduced emissions in the last 10 to 20 years by a significant amount, and the same cannot be said for fossil fuel emissions.
I think that's a good note to end it on. Thank you very much, and I wish you good luck with your results. You could be changing the way the negotiations go in some part.
Maybe so. Thank you very much.
Thank you.